Okay, so from part 1, we had the fact that we have had these 5 here, roots. The r was just whatever the new r, take the 5th root of this r, and then we separated them up. Notice that each time we do this, when we actually went through all these different 8, 16, 24, 32, they were all 8 pi over 4 more plus the 3 pi. In other words, the numerator went up by 8 pi over 4, or by 8. Okay? And up here, 0, 2 pi over 3, 4 pi over 3, every 2 pi over 3. And then you can, again, those roots were from these up here. You could see how these angles from here to here to there to there almost looks like we would put in, or we could put in a rows of that many petals, and those would be where your values would be. So we can use that as our fact of, maybe instead of thinking these formulas there, you can use the formulas, but a way of maybe thinking about it in a different way for those spacings. So we're going to go ahead and do that with this. Find the 4th roots of 9 cosine of 256 theta plus I sine 256 theta. Okay, so the 4th root in is 4. So the new r is the 4th root of 9, which is the square root of 3. Huh? Remember this? Oh wait, that's 3 to the 3 squared. I'll rewrite that for you. We do want to do this, by the way, especially if they come out to be nice. Make it a little nicer. So that's 3 to the 1/2. Okay, so now, so there's our new r, our thetas. Well, the first theta we deal with, so I'll say theta 0, is take the angle divided by the index. So 256 divided by 4. Now, why do I start at 0? Good place to start, like, oh, maybe the original one? And then what happens to the next one? Now, so now when we're thinking about it, we have 4 roots around a circle. How do we space 4 roots around a circle? What are we going to add? Plus what theta we're going to add? Yep, just like we did with the rows. So we're going to keep adding 90. So 64 plus 90. Oops. 90 again for this, for 2. 90 again for, quote, the 3. Now, if you got carried away and went ahead and did it again, add another 90, you'd have, okay, 30, so that would have been 424. Wait, that's too big, so I'm going to subtract 360, and we get 64. Oh, look. Ding, right there. And we don't do that. That's why we need 4 total. 4 total. If you would have used the formula, let's just say for this one here, so 256 plus 360 times 2 over 4. So 256 plus 720, that's what, 976 over 4. Ooh, that's the problem about degrees. They get really, really big, really, really quick. So anyways, so that's what we could do. We could picture like we're creating a rows with this many. So the space, where's the first one, or the original one, is the original angle, the original theta, its original direction, divided by the index. And then go from there. Now, instead of writing square root of 3 cosine 64 degrees plus I sine 64 each time like we did here, there is a short form for this. And yes, you can write it. Now you're not going to see it anywhere for me on any of your papers, so the question isn't going to show up using the short form. I get to type it all out. But I'm writing this out now. What is the short form? Let me just finish this last one here. Okay. The short form is this here. It looks like this. R cis theta. Now I write the I this way just to to indicate that looks like the imaginary root is really just saying this. So it's the short form, condensed form for this. Now, if you don't know what this means and you're using it, and you turn around and need to go ahead and go, wait, what does this mean later? Then don't use it. So you could have just went ahead and said, like for this one would have been 3 CIS, which just means cosine plus I sine theta of 64. Or, oops, not 3, square root of 3. Square root of 3 cosine of 150 CIS, which means cosine of 154 plus I sine 154 degrees. And you can do that for each one. So we can use this form, but you better know if you have to change it to standard form what it means. So it really means this. Okay, so this is not required, just something if you want to shorten your form up. Fourth roots of unity. Huh? Yes, we always like to be unit. United, right? But what is of unit? Which is what number? So when we see roots of unity, we're really thinking, what are the roots? The fourth roots of 1. Or the fourth roots of 1 cosine 0 plus I sine 0. That's all. Okay. Let's see. Degrees, radians. Let's use radians in this one. I don't want to deal with the big numbers. So, what's the fourth root of 1? Again, boring. That's always going to be 1. Theta. If we use the shortcut, not the shortcut, sorry, the pattern to it, as opposed to plugging in the formula, the pattern says, okay, for the first angle, when I say the first one, the quote original one, we take the direction divided by 4. Now, the spacing, fourth roots, 4 units. So we're adding pi over 2 to get the next 3 of them. So 0 plus pi over 2, pi over 2 plus pi over 2, pi plus pi over 2, and then the number. Short form, so 1 times CIS of 0, 1 CIS of pi over 4, 1 CIS of pi, 1 CIS of 3 pi over 2. Now, I'm not saying you can't. I'm just saying you can do this, because our book, I don't believe, shows this, and it's sort of gotten away from it. Why? I don't know, but I like it. Writing them all out this way instead. Again, in terms of what you're going to see on any assessment, anything I give you in terms of working on it will be the typical quote long form, but if you'd like to write it down as the short form because you don't want to write out 4 or 5 different things or more this way because it's a lot of writing, tedious, write them this way. Done. That would be acceptable for me in your writing. You're not going to see it, but you can write them that way. Okay? Get working on your practice. Oh, by the way, again, the whole reason we're doing this, why do we do all this stuff? So if we get to equations like this, we get the cube root of 8, we can then use these roots to get that. Or what if we would have turned around with an equation like, oh, something really looking strange, maybe like x to the 4th plus, oh, I don't know, how about 16 equals 0? Those are all imaginary. What are your 4 imaginary roots? Because you get x to the 4th equals negative 16. Well, can't do it without the trig form. So we change that to trig form, take the 4th roots by what we just did.